Hello everyone, welcome. Let's talk about Spring. But before we do, I'd like to ask you a few questions, just to see in which kind of room I'm giving a talk. So raise your hand if you consider yourself a Spring developer. That's pretty much everyone, interesting. Raise your hand if you're using Spring Boot. Perfect, same. Spring Boot 2? Okay, so if most of you are using Spring Boot 2, for those who aren't or are not a Spring developer, do not worry. I just have a few slides and then it will be mostly live coding, so you'll get a chance to hopefully have a feeling of what I'm trying to convey here. Spring Boot 2 brought a new option to develop web applications or applications in general, but particularly web applications with a reactive stack. And a complete reactive stack that's also included in the rest of the portfolio. So Spring Data, Spring Security, Spring Integration, etc., etc. Who knows about reactive programming here? All right, that's probably 20%. Okay. So if we look at this diagram, it's basically laying out the two options that you have, and we've been telling you a lot about it the past 2 years, that you can choose one or the other, and more importantly, that the MVC stack isn't going away. It's always a problem when you introduce a new options, like you can be afraid that actually the thing that you're using is going to be deprecated and ultimately removed, and you have to rewrite everything. That's not the case at all. So this is not a talk about reactive, so I'll go quick on that. But in a nutshell, on the right-hand side, you have the servlet stack, so the regular web application, if I can call it like that, where you have one thread which is processing one request, right? So you have an incoming request coming in, one thread is allocated to it, it runs the whole processing, writes the response of whatever the business logic is supposed to provide, and then that thread can be reused to do something else if another connection comes in. Problem with that is you have a limited amount of thread, so if you want to scale, you need to add more machines, and that can be a problem, and that can be costly. The reactive stack, however, is changing the game with an event loop, where everything you do is declarative, so you basically express the business logic, and there is an engine that will basically call you whenever the data is available, or whatever you're looking at is available. So if we take an example of accessing a database, and the database is slow, or the network is slow, or whatever, on the servlet stack, your thread will be blocked, will be waiting for the data. With the reactive stack, it won't. It will do, the server will just do something else, and once the data comes back and there is some resource available, the request will resume. That basically also means that you no longer have this notion of one thread per request. Right, so if you're interested by that, there's a bunch of video on YouTube about it. This one is really not about that specifically. It's really about showing you there are additional options. Right, it's not either the servlet stack or the reactive stack. There is a third option where you can use your servlet stack and basically use some of the reactive features. So basically start small for some use cases, and maybe you'll figure it out that it's actually generally applicable to your application, and you can migrate that to the reactive stack. So enough with the boring stuff. Let's go live coding. And I just have like a few more slides to tell you a bit about the app that we are going to use today. So this is StarterSpring.io. Who knows StarterSpring.io? Just making sure you're awake. There must be more hands. There must be more hands. Who knows StarterSpring.io? Come on. Everybody knows StarterSpring.io. If you're a Spring developer, should be. Okay, good. Perfect. So getting started, and every time you get started on StarterSpring.io, we actually take a snapshot of your preferences, so that's a way for us to understand how the community is using the service. Oh, That's my old slide that was the Halloween theme of last month, sorry. Anyway, it's gone. So every time you generate a project, we take a snapshot of your preferences and we store that in an index. But it could be any client, right? It doesn't have to be the web interface. It could be on the command line. It could be in your IDE. You know that you can use that in your IDE, right? You don't have to go to the web to generate a new project. You can do that right from your IDE. And what we are going to do today is we are going to work on a dashboard application. And that dashboard application, for the example here, needs to fetch data from 3 different services. So there's the project one. We already know about that. It's giving us how many projects were generated for a given time frame. There is an events service that tells us about stuff that happened in the time frame that we are interested in. And there, and there's an IP lookup service that gives you back IP addresses of something that might be abusing the service, whatever. It's for the sake of the example here. And we don't want to look at IP addresses. We want to look at resolve name because we're humans. So there is also a service that you give it an IP, it will give you back the name. And of course, you can't give it 10 IPs and get back 10 names because the API is like that and you can't change it. You have to call it one at a time with one IP at a time. All that for the purpose of what I'm trying to show you today. So, all right. So I have my app running. And this is it. So this is what we are going to work on. You can see that on a single page, we get some data about project generation. So that's the 3 generation that we have right now. You can see that Slack being down there, developers felt depressed and stopped creating projects for some reason. And then you see the wonderful resolution name that I wrote. I'm very proud of it. As you can see, it's very informative. All right, so if we look at the, let's look quickly at the endpoint themselves. So they are running now on 8081. Just to tell you, there is no magic there. So this is the first endpoint. You give it a time frame, and it will give you back some data. There is also, where is my events? There is also the events one, and there is a top IPs one, right? So this is what we are going to compose. Okay, so let's look at the code now. So this is a Spring MVC application using the REST template. So this is really the API. If you've written a web application in the past, or any applications that need to contact a remote service, you probably have used the REST template. And if we look at really the main method we are going to spend some time on, this is it. So as you can see, you get a time range. Then the purpose of that is to create a container with the statistics, the events, and the top IPs. And you can see that this happens as 3 different calls. And once you get the IPs, there is also some kind of smart optimization there to resolve the IP with the name. And as you know, if we're talking about an MVC-based app, you have one thread. So if the first service is slow, the thread should just wait, right? Or the second is slow, you just wait. And you can't optimize anything. So you need to get the IPs. You get to buffer the list of IPs. And once you've buffered the list of IPs, then you can loop over them and get the actual name for each IP. So let's try to optimize that using some of the reactive features that Spring Boot 2 gives you. And one way to do that is to bring an extra starter on this application called WebFlux. And WebFlux it was on the first slide, it was on the left, on the right, I forgot now, but anyway, the reactive stack is implemented by this, this starter. So the first thing I want to do is I want to change my web client to something that can use some of the reactive features. Because here, there is some latency and some I/O involved, but you can't see it in the API, right? You see that you call a method, and method may take some time, but you have no way to control that. So there is a new API called WebClient. Here is a component that Spring Boot provides me with all kinds of defaults. So serialization strategies, logging, security, whatever, that you've configured or Spring Boot has detected will be applied here. So you, rather than creating the REST template yourself, you inject the builder and then you have a chance to customize it, and you keep Spring Boot defaults. Of course, if you don't want that, you can create your own. So there is the same for the web client. There you go. So I have now my web client configured to contact my service on 8081 by default. So let's change let's actually change the API has changed a bit. So just doing that quickly. And the first thing that I'm doing here is, rather than returning the data, so the statistics, I'm returning what's called a mono. So mono is an implementation of reactive streams publisher interface. So the core mechanism in reactive, for those who are not aware of that, is a publish-subscribe model, where you have a publisher that can provide data. So you define something that will provide data. So in this case, I'm defining a publisher that ultimately will give me some statistics information, and it's using a web client to achieve that. And you have a subscriber, and the subscriber is the thing that's interested by the data and potentially will transform it or process it once the data arrives. Mono is a specific implementation of publisher that emits 1 or 0 element. And there is a different implementation called Flux. And Flux can emit 0 to n element and potentially an infinite number of elements. So we can see here we have a list of events, so we can use Flux instead for that. And I'm going to say same thing, right? I'm going to say get URI, then I'm passing the parameter over here, retrieve and body to Flux with the event class. Right? Okay. So there's a bit more to do, and I'm not going to do that now. So let's check out that and restart my app. So what has changed in this commit is this, right? So I'm not returning the data anymore. I'm returning something that eventually, when there are resources, when the remote service has replied, I will be able to process the data. So I need to subscribe to it. If I don't subscribe to it, there is no way for me to get the data. So this is actually a very intermediate solution here, because it doesn't give you anything. It doesn't give you any optimization whatsoever, except maybe now you see in the code that there is some potential latency. So you can see now that I'm actually, we used to do that before with the REST template, right? It's exactly the same. We used to block to get the statistics, then we do something with the builder, then we block for getting events, and we do something with the builder again, then we block for the clients, etc., etc. And if we go back to the application, I need to log in again because I've restarted. I still have it, right? This is my application. So it's not very interesting. So let's try to actually use some of those reactive features. And one thing you would do with imperative is, if you want to parallelize that, you would create a thread pool of some kind, right? And you would invoke those 3 things in some completable future or whatever asynchronous processing that you have, and then join them, and then end the timeout and end the exception, and it's a nightmare, right? It's no fun, I should say. So if you've done that in the past, you know it's a pain, and you know it's in your way, and you should probably focus on business logic and not that kind of low-level stuff. If you want to focus on that kind of low-level stuff, you should write a framework. So reactive does that for you in quite an idiomatic way, I should say. So I want to show you how. So the first thing we want to do is stop blocking here and keep those publishers around. Right? Let's put it there. Remember that the that method actually used to return a flux, and you can see it's. Oh, sorry. Actually, I should show you that completely now. It doesn't return the flux, but the list. That's because there is an operator applied to the method call called collectList. And collectList, what it does, it's an operator on a publisher that will accumulate the elements. And once the publisher said, I have no more data, it will emit a mono with the list, right? So it's a way for you to get the intermediate elements and just get one signal with the list, because you don't care about the intermediate elements. You don't want to process events as they come, right? You don't care about that. You just want to have the list of events and move on. Okay, so let's also get our top clients. So that's a reverse lookup descriptor. Let's call that top IPs. I need to implement that. And I want to work with a flux again because it's more idiomatic. So I'm going to apply the same method there, collect list. And for some reason, IntelliJ didn't catch it was a reverse lookup descriptor. Right, okay. So what do we need to do? We need to call the IP service, get the IPs, and then get the names. So as you can see here, there is more optimization you can apply. So what you could do is you could, while you're receiving the IPs, right? You get the data back from the server and you're deserializing those that JSON data. You can, while you're getting those elements, you can call the DNS lookup service to get the name. So you don't need to buffer the list. You don't need to store the list in memory. Of course, this is a silly example because you have a list with 10 strings, so probably not the thing you want to optimize. But assume that you're dealing with a lot of data and potentially large amount of data. You may want to process the data while you get piece of it, and that would be useful. So for that, I'm using FlatMap. If you've used the Stream API in Java 8, you probably know what that does. So FlatMap will subscribe to each element, and you'll get a chance to transform the data that way. So transforming the data, what do I want? I want this. So let's call that client. Of course, and client get IPs. Go away. Okay, so I have my flux of reverse lookup descriptor, and in this case again, I'm not interested by getting every name. I just want the list of names, because that the business of that method is to feed the container with the data. Okay, so I was talking about that thread pool, right? And you don't want to play with that. Once you have publishers like this, there is a way to tell the reactive implementation. This is the project Reactor, by the way, if you're interested. That's what we are using under the hood in Webflux. You could tell Project Reactor, these are some publishers that will ultimately give me data. Just call them, subscribe to them. I don't care how, I don't care in which order. Just do it in an optimized fashion. And to do that, there is an operator that's called zip. And zip takes a number of publishers, and it will subscribe to them. And once that data comes back, then you can map that to something, right? This is what I'm doing here. Let's remove that. We don't need it. Move that here. There we go. All right. So on my tuple, T1 is the first argument. The events are T2. And the IPs are the third arguments, that's T3. and I'm returning that. Or not, by the way, I could block here. That would be one option. But I want to show you a bit more. And if I'm looking at who's using that stuff, this is my controller, which is feeding the model and then giving that to a view, and the view, I think it's time leaf here. The view is actually rendering my page here. Ooh, ooh, why not? What did I do wrong? Yeah, I know. That's unrelated, by the way, if you're wondering. I meant to show you that after. Whatever. All right. So my app is back. It's optimized. But the server is fast. So what I want to do is I want to slow down the server. There we go. So I have a service on the generator on 8081. Let's put that back a bit above so that you can see it. And previously it was not doing anything, and I just changed it so that 80% of some request of something, we don't know what it is, will be slowed down artificially from 200 milliseconds to 8,000 milliseconds. So it could take up to 8 seconds. There is a randomizer there for 80% of the request. So I press refresh, by the way, if you don't see it. So it's really slow now, right? So we have a problem. And how can you figure out where the problem is, right? You could dig in the code, debug. I want to show you how you can easily debug this application. And as of Spring Boot 2, we integrate with a new library called Micrometer. Who knows about Micrometer? Okay, that's 10%. Interesting. So if you use Spring Boot Actuator, which is our production-ready starter, which is already used here, you'll get Micrometer with it, with Spring Boot 2, and that's a way for you to define metrics and also monitor some components of your application. And one decision that you have to make as a developer is to export those metrics in some system. And you could choose JMX, you could choose Datadog, you could choose Prometheus. So Micrometer is actually that. It's a facade API with a bunch of implementation called registries for monitoring system. Okay, so let's use Prometheus. So I'm going to add an optional dependency to get that. If I can type it. Come on, it's not registry. It's this registry. So these are the implementations I was talking about. What's the name again of that thing? Oh boy. When autocomplete doesn't work. Okay, start typing. Okay, I'm bored. That was IO Micrometer, fine. Sorry about that. So if you add that, the metrics that Spring Boot monitors by default will be exposed to Prometheus, and I'm going to show you how that can be quite interesting. So that commit actually added two more things, really. One, it added this tag called application. So you will see in a minute that each metrics is actually has a number of tags, a number of labels, if you will. And it's a way for you, if you have, of course, you have a single monitoring platform potentially, monitoring thousands of applications. So when you look at metrics, you need to know from which service it's coming from. And tags is a way to do that. So this line there that's highlighted in the config basically says every metrics you expose for this application should have a tag called application, and the value should be initializer dashboard. So that's a way for us to track that. And the other thing that it did, I meant to show you that in practice, but the other thing that it did is because this application is using security, as you've seen me logging in as admin, you need a way to tell Prometheus how to get the information, because the way Prometheus works is it's calling you, right? Most monitoring system will be in the form of an API key, and Spring Boot will push metrics to the monitoring system. Prometheus is different. Prometheus actually calls the application to scrap, to grab metrics. And we expose the endpoint that Prometheus is expecting. Of course, Prometheus needs to be able to access it. You should configure Prometheus with whatever security you have in place, but of course I have a demo, so I'll just give him access with permit all. Okay. So I have my job here. As you can see, I have a job called Spring, and every 5 seconds, it's going to scrap metrics from my dashboard and my backend. We're not going to look at the backend, but just wanted to show you that with one config, you can actually scrap many instances. Okay. So Prometheus is on 1990, I think. It is. Perfect. Okay, so that stuff is still very slow, right? So let's have a look to these are the metrics that are exposed. I want to check at HTTP something. There we go. And these are the tags I was talking about. And I'm going to highlight, can you see it? Yes, you can see it. I'm going to highlight one. You can see it's coming from the initializer dashboard, where you don't see the dashboard because it's on the left. Then you see a bunch of tags. Like you can see the instance, the job. In this case, since it's a metrics that's specific to HTTP, you get the method and the outcome, and also the URI and the max time, because the metric I'm showing you now is give me the maximum response time on that server. And you can see it, strangely enough, it's very close from 8 seconds. Right? So what that tells you is by changing from REST template to web client the way I did it, everything has been optimized up to a point that the slowest request is actually your response time, pretty much. But looking at that is no fun, so let's look at that in Grafana. Who knows about Grafana? So everybody knows about Grafana, but nobody knows about Micrometer. That's interesting. I guess we need to do some marketing there. So if you have Grafana, once you have Grafana, since all of you seems to know it, you can plug a bunch of data source. There's a Prometheus data source, and basically it gives you an interface for your application. There's also a dashboard, which is the dashboard I'm showing you now, that's available on the Grafana website. So if you search for Micrometer, you can download that dashboard and add it to your local instance, and it will give you some of the things that Spring Boot will monitor for you. But I want to show you a bit more, so I'm not going to show you how to add your own because you seem to know that already. But I want to show you what the problem is. If you can see that, I think you can. So this is the client side now, statistic for my service. So Spring Boot will monitor the server automatically. So whenever there's an incoming request to the server, we'll time that out of the box. And if you use the REST template builder or the web client builder, as I was explaining earlier, and metrics are enabled, then automatically you'll get metrics for that as well. So this is the client side, so the client side of the server side, if you will. So this is the code that I've changed to use web client. And you can see the culprit. If you look at the max time per endpoint, you can see that it's calling something reverse lookup, and there is a free in the name, which gives you an indicator that it's probably crap. So you have a reverse lookup, which is free, but doesn't work very well. You can see that the current max time is around 7 seconds. So we want to change that, and we can. We can because if we look at the reverse lookup client, if I find it, there we go. I also have one I have to pay for the purpose of the demo. So every time I'm calling it, I have to pay. So the deal here is I don't want to switch from the free one to the one I have to pay, because if the free one is good enough for my use case, I might just as well use that and not pay. But if at some point the threshold, the performance threshold of that service doesn't match what I want, then I would like to, I'm willing to pay. And of course, if you want to implement that the imperative way, yourself, it's quite of a challenge as well. So I want to show you how you can easily do that with the infrastructure you have in place. So remember this method, right? This is invoking the free service. So this is returning a publisher. And because it's returning a publisher, it's actually returning a mono of the descriptor, I can use any operator that the project reactor gives me. It doesn't matter that the thing that gets the data is HTTP or not, doesn't matter. So for that, I'm going to, if I'm on the right thing, yes, I'm calling timeout. Oh boy. The god of live coding are not with me today. So I'm going to call timeout, and as you can see probably for those in the front, there is a bunch of options you can choose. You can figure out what the timeout should be, or you can hard code the timeout, which is what I'm going to do now. So I'm going to say half a second, and if that's achieved, then I want to look up client, of course. I want to use the paying service, right? So this is very idiomatic, right? You're describing what you want to do. I'm calling the free one. If it lasts more than 500 milliseconds, give up and just call that free service. So the difference now is you can see it's much more faster now. And I want to spend a bit of time now, I think I have like 5 minutes, to talk to you about what that duration is and how it works a bit under the hood, and why a project reactor helps in this case. So we subscribe to get the data for the free service, right? So we say, okay, I'm interested by this. And the timeout operator, what it does, it's wrapping that, and if after 500 milliseconds it doesn't get the data, it's basically say cancel. So it's if you look at the reactive streams API, you'll see that there is a method in the interface that's actually done for that purpose. You're basically saying to the component that gives you the data, give up. Don't give me the data. I'm not interested by that anymore. And you will leave to the implementation of that publisher the job of canceling whatever needs to be canceled. So if we look at the implementation for HTTP, what it will do, it will close the connection potentially, or cancel the request on the server, or whatever needs to be done. And then it will call the other one transparently for you. So if we look at the max now, you can see that the max is at 447 milliseconds, so very close to 500. So as soon as you go above that threshold, you're calling the paying service. And we can also see here, I told you about labels, right? Labels is also a good way for you to categorize metrics. So you have a way now to see the usage of the free service versus the costly service. And the more you diminish the timeout, the more the paying service is going to be used. So you can also monitor the usage of your paying service and then maybe figure out if you have to change provider or change strategy or whatever. So that thing doesn't work. How much time do I have? 5 minutes. Okay. Right. So this is also, there is also one thing I would like to show you very quickly. It's how you can add your own metrics. So let's have a look to that. It's in the lookup client, of course. So the free service has plenty of faults because it's free. And one of them, it has a rate limiting. So if you call it, if you abuse the service, basically you'll get denied at some point. It's a rate limiting implementation. And it's implemented in the form of a header, the same way you would find in GitHub if you use a GitHub API. And once that's number is gone and you try to use the service, you'll get denied, right? And you would like also to monitor that. So one way to do it is to create a filter. So this is really a component of the WebClient API. For REST template, you would use a request interception or request interceptor, I think it's called. But this method is adding a metric to your system. So you have the meta registry, you create a gauge, so something that can increase and decrease. You give it a name, and the type is of integer. You get that back, and once you get that back, your implementation is responsible to set the value, basically. And the way you set the value is by using the filter. Every time you get the response back from the free service, you get the value in the header, and it gives you the number of calls that you have for that minute. And then you just set it. So this is what I'm doing here. I'm basically setting the atomic integer, and the atomic integer behind the scenes is going to update the gauge. Okay, so let's try that. I'm not sure. Yeah, okay, there we go. So you can see it refreshing. So that's a custom component here on the left. Tells you have 80 calls remaining for that minute, and basically the bucket fills in when you're not using the service. When you're using too much, at some point, it will crash like that, and you'll see you'll be at 0 here. Of course, there is a lag between the actual event and the fact that you can see the dashboard, and also the bucket actually fills in. So, but you can see it's at 0. So when you think of it, this is also something you could implement with Reactor, right? You could, on that call, you could plug something that would react to the fact that you've achieved rate limiting, and then for a period of time calling the paying service, and then at some point check and go back to the free service again. So I've shown timeout, I've shown rate limiting, and there's a bunch of other things that you can do with that API. If you want to play with the application, this is the link. Don't worry, I'll also tweet the link today, so that if you see, with the hashtag JFuture, so you have a chance to get it if you missed it. And I think we have some time for questions. Thank you.
Thank you.